Okay, 9-4, we're talking about rotation. And rotation is pretty simple. It's actually very, very easy, but we're going to talk about matrices as well as we get going through this. So say rotation. And rotation is typically counterclockwise, unless we say otherwise. Okay. Counterclockwise. All right. And rotation is about a point. So I'm going to start and just put my point at the, actually we'll just do this differently. I'll put my center of rotation right here, my point of rotation. And I'm just going to draw a figure up here. Okay. It doesn't matter if you draw the same picture or not. That's not what we're doing here. All right, so I'll just say A, B, and C. Now, to do a rotation, I'm going to do a rotation of, give me a degree. Not 90, not 180, not 270. 60. 60-degree rotation counterclockwise. That means to the left. So all you do is this. You put the center of your protractor on your point of rotation. And this line here needs to be on one of the points that you're doing. So it's supposed to be here, so I'll just do B first. What's up? How many? I don't think it has. I try not to keep them. This is on.
Yeah, that should be.
Yeah, great. Actually, I think those may be for this Scantron here, which doesn't work. So, what is it? What does it say those are?
Grade masters.
Okay, that's probably right. Okay, so I want to put my point at the rotation point and the line on whatever point I'm rotating. And then I find 60 degrees, which is right here, which is across from one. Excuse me. Exactly across from 120. So that's my 60 degree. I'm going to draw a line up to that. So from B to this line, rotated about this point, is going to be 60 degrees. Now how do I find where B prime is? I have to measure it. So I'm going to use my centimeters and millimeters to be a little more accurate. So from point B to, we'll call this point P. That is 2.2 millimeters. So I'm going to measure 2.2 millimeters. And that right there is my B prime. And I'm going to do that for each of these. So again, I'm going to put my point at P. I'm going to do C this time. And I find 60 degrees, which is right there. Draw another line. Measure PC, which is 1.3. And there is where C prime is going to be. And now I'll do A. Center of P, line on A, find 60 degrees, draw the line, and now measure AP. And this looks like right at 2 centimeters. So there's A prime. Connect all those dots. And there I just rotated my pre-image to my image. Remember, this is pre-image here. What you start with is your pre-image. That's a 60-degree rotation. And if you do that e-learning sheet, the program looks just like this. You can move this around with your finger, and then there's a bar up here where you can change how many degrees it rotates, and as you scroll across there, the image rotates around. So it's kind of helps you to figure out some things. You can also pick a point and move a point, and it shows you how it moves the actual point that's on your image picture. So that's what that program is. It's kind of neat just to look at, just to see how things work. But you're going to do this, okay? That's how you rotate things about a point that isn't at the origin and isn't 90, 180, or 270. So that's a rotation. Rotation is also an isometry. What I want to do now is kind of talk about what you get when you do 90, 80, and 270 degree rotation. So let's just take a point here. We'll take 4, 1. And what I want to know is what's happening to x and y when I rotate it 90 degrees counterclockwise. So here's how we do a typical easy rotation like this. 90 degrees counterclockwise is just rotating your paper to the left, a quarter turn. That's it. Now what is that coordinate? If that was upright right now, what is that coordinate? Negative 1, 4. So, negative 1, 4. What happened to x and y? They switched. So y became first and x is second. What else? Y became negative. Pretty easy, right? Okay, so in your book, if you have it, you have an A and a B. Basically, it's negative B and A. Okay. That's something you should remember. Now, remember when we multiply matrices? How do you write matrices for coordinates? How do you write those? X is on top and Y is on bottom. So I'm just going to put X here and Y here. I'm just going to use 1 point since that's all we have. Now remember, when you multiply matrices, you take the row times the column. So whatever's in this first position, I'm going to multiply by X. So that means I have to have 2 entries here, because I have 2 entries in my column here. So this entry and that entry, I'm going to multiply by the X and the Y. Now what was my answer here? A negative Y and then the X. So what am I multiplying X by and what am I multiplying Y by to get a value of just negative Y? What happened to the X? It disappears, right? Well, what do you multiply by something to get it to disappear? 0. So this first entry must be 0 because 0 times X is 0. The X is now gone. And what am I supposed to do? Add that to the next multiplication. Well, what times Y gives me negative Y? Negative 1. There's the first row. Now I still got to get X down here in the second row. Alright? I want X, I don't want Y. So what am I going to be multiplying Y by? 0. So the 0 is going to go in this position. What am I multiplying X by to get X? 1. And that is your 90 degree rotation matrix. This is also in your book. You can look at it, memorize it. I just want you to see that you can figure this stuff out if you had to, if you forgot it when it comes time for the quizzes and tests. It's going to take you some time, but you could figure it out. Okay, so that's your 90 degree rotation matrix. That's what you do to your X and Y. Okay, let's talk about 180. 180 degree rotation counterclockwise. Let's pick something different here. Something a little harder. How about 2, negative 3? Okay, so 180 degrees just means upside down. What is that coordinate? Negative 2, positive 3. So what happened to the X and the Y? They stayed in the same place, but they opposite signs. So negative X, negative Y is really what a 180 degree rotation is. It doesn't matter if it's clockwise or counterclockwise, you get the same answer for 180 degrees. Okay, now my next question is, what am I going to multiply by to get a negative X and a negative Y? So again, I got to take this row times the X and the Y. I want to get rid of the Y, right? So that one's a 0. What am I multiply X by to get negative X? Negative 1. Okay. Now the second row, I want to get rid of X, so I'm going to multiply by 0. What's the next one? Negative 1. So the 180 degree rotation is an easy one to remember. It's the 90 and the 270 that students switch on accident. So we need to make sure we got that. Let's do a 270. So I'll go ahead and pick negative 3, negative 5. And I'm picking just weird ones. I could just stay in the first quadrant, but let's just try to make it different, okay? So, 270 to the left is really just 90 degrees to the right, isn't it? Alright, so what is that coordinate? Negative 5, positive 3. What happened to x and y? They switched, first of all, right? And then what? X changed signs. Did y stay the same? Yeah, y stays the same, so y negative x. Look at the 90 degree rotation. They switched, but the y changed the sign. Alright, so there is that. Let's talk about the matrix. What we're going to be multiplying by to get y and negative x. Again, x is gone, so in the first row, that's 0. What are we multiplying y by? Positive 1. In the second row, we're getting rid of the y, so that's a 0. What do we multiply x by? Okay, now look at the 90 degree. The 90 degree and the 270, they're just switched. Okay, so make sure you don't mix those up. That's how you do the matrix stuff. Rotation is an isometry. One last thing, if we put a little algebra in it, let me show you what the book has here. We'll just do one of these at the bottom. Triangles rotated about P. Find the value of B. Now here's the important part. You really need to know which sides correspond to which sides, okay, the corresponding pieces. So if I just take this and went like that, what does 2a plus 6 match up with? 4b. Alright, so let's just write these out here. 2a plus 6 equals 4b. That doesn't really help us. What else? What does 3a match up with? 15. So 3a equals 15. We can solve for a then, can't we? What's a? 5. If we can solve for a, 5 times 2 is 10, 10 plus 6 is 16. What's b? 4. And then I don't need to do that, because first of all, 3b doesn't match up with anything. I couldn't do anything with that. Did we answer? Find the value of b. We just did. b equals 4. So, yeah, you can bet something like that will be on the quiz and the test. So, and also, let's just make sure we can do the rotation stuff. How to do that. All right. Homework. Page 602, 3 to 23 odds, 33 to 55. So I want to make sure you understood some of your homework from the other night.